Hey, welcome to episode 4 of Cryptenomics. Today we're going to be extending our conversation from last time into the more technical side, speaking about the scaling of blockchains. Last episode, we spoke about business obstacles and business opportunities that are in the way for the industry to scale from a business perspective. Today we'll be tackling more of the technical side. But before diving into this, Aaron just brought up something really funny to me because we're always talking about crypto, and you had some funny Verge news you wanted to bring up.
Yeah, so I read about this over the weekend, that Verge was doing a crowdfund where they're trying to raise like 75 million Verge, which amounts to like 3.5 million USD. And this is just a crowdfund. There's no equity, there's no ICO, you're not receiving a token. They're just asking their community
to give back
for money. And they followed up the initial request with a tweet that kind of hyped it up a bit, indicating that they have some mysterious partnership in the works with a huge company or corporation or entity. And this crowdfund will help them kind of make that materialize. But they weren't revealing who the partnership was with. And they said that they would reveal it if they met their fundraising goal of that 75 million Verge. So I think that came and went this past Monday or so. And I think we're still waiting on news as to what...
Did they get it?
They did. They met their funding goal. Yeah.
What the hell?
So yeah, they tweeted that like big thing is coming soon. They're going to reveal what the news was, but nothing yet. And
real quick though, like screw Verge. McAfee was pumping it. If anyone's curious, I'm pretty sure Verge used to be called Dogecoin Dark.
Dogecoin Dark.
If that's telling of anything.
This was like the original parody of the original shitcoin.
Yeah, so I don't know. That's hilarious. I can't believe people gave that. Anyways, let's dive into the scaling. So, last episode we went through the business obstacles, business opportunities, any blockers that's stopping the industry from growing. But there are also technical things stopping the industry from growing.
Yeah, so, we have, limits on the number of transactions that can be processed per second. We've seen, CryptoKitties, which was, I think, a great project and still continues to be a great project that will bring more people into, blockchain, even if it is silly and kind of trivial. It is providing some real value to the community. But when that first came out and that, became huge overnight, we saw the Ethereum blockchain come to almost a halt. So that I think was revealing of a lot of the limitations on Ethereum's blockchain. But overall, we know that there are limitations we're encountering. And I was reading that from the Ethereum core or Vitalik and his team's perspective, CryptoKitties was actually great. The fact that it brought the blockchain to that halt was very helpful to them, for them to see where the bottlenecks are, how things need to be improved, where the biggest issues lie. So while it wasn't great, it didn't show that Ethereum is ready for the prime time that we're hoping it will be. But it is a necessary step in kind of growing. So yeah, there's definitely a lot of limitations. I thought we could step back for a second and just talk about what's happened to date, what we've tried to do to scale. So.
And I've seen, I'm in a lot of random Facebook groups, a lot of random Telegram groups, Discord groups, and there's a lot of people who try to take an opinion on this, but they don't really understand even the basics, right? So there's all these terms being thrown around, like sharding, block size, plasma, and scaling in general. And I feel like people, maybe it's worth taking a minute to explain Lightning Network. But I feel like at the core, people don't even know what a database really is. It's not a very difficult thing to understand, but very quickly, there's ways, maybe we should explain the relational database type of scaling, what sharding means.
Yeah, so...
A database is just a table, for people to just visualize, that's all.
Yeah, so when you have a traditional relational database, it's this table. You have columns and rows. Your columns represent different fields,
it's
data
like an
points.
Excel spreadsheet.
Yeah.
Active Excel spreadsheet.
It is a table very much like that. And this is, again, a traditional relational database. So you have these columns and rows, and as your database grows and you have millions, so each row is an entry. And
like if you have a database of names.
Right. So if you have users is a great example. So if you have a database of users or a table of users. So your columns will be like, you'll have a ID column, which would be, a unique identifier for the database. Typically that's just an integer that increments. There are definitely some more complex types of unique identifiers, but for now, then you could have other columns: first name, last name, email.
Country of origin, random, any facts you want
Yeah,
about your users.
data
your
points that
application.
you'll be saving about each user. So each row then represents a user, an individual user. So one row will have ID 1, and then next to it will say Mike, first name, last name, Rosenblatt, and it'll continue down. So that's your traditional relational database. Now, as that grows and you have millions of these rows, millions of users in your database, the load on that database becomes pretty significant, and you want to try and mitigate that. So one of the classic methodologies for scaling relational database is called sharding, and that is basically
Not pooping and farting at the same time.
sharding.
Sharding with a D. Got
With
it.
a D.
Okay.
So that is really horizontally partitioning your database. So you're basically taking groupings of rows and you're separating them. So now they're on different databases, and usually there's some function or logic for how these are mapped, so you know where to look for a given row. So if you're looking for a row, Mike Rosenblatt, you know that he's on database server 1 or database server 5. And again, these are now your users are split out across all these databases.
So real quick, if you have, let's say, 500,000 users on your application, you have some mobile app, right? And you have a database of all of these users. And you have last names, A through C, D through F. Well, really A through Z. But instead of having A through Z, all the users in one table, in one database, you could have it be A through C in one database, then D through F,
Exactly.
then G through H, and so on different servers on different databases.
And there's some logic so that you know where to look for a given user.
So if you have to query for some user that has a last name starting with V, instead of starting at A and going down, you can go to the database and start right at T and look for the T through V.
Yeah, that's a bit of an oversimplification, but it's definitely like the right idea. Basically, when you're querying a database that has 500 million records, the processing time for that query is going to be pretty long. Whereas if you're only querying a database that has 1,000 records, and that's your lower level letters, then that query is going to come back much quicker.
Gotcha.
So yeah, that's the core of sharding, and really just about all of these methodologies that people are trying to scale the blockchain with come back to this. Minor technical hiccup there. We're back. So digging back into sharding, all of these methods for scaling the blockchain, they come back to that traditional method of scaling relational databases, sharding. Now, sharding, specifically referring to blockchain in Ethereum, is specific. There is Ethereum's sharding, and that we'll get into that. That's one of the methods Ethereum is trying to scale with. But there are a bunch, and again, at a fundamental concept level, they all kind of come back to that, splitting the data up so that there's less going on at that
in
core
each
level.
individual database table.
Right.
Yeah.
So we can jump right into off-chain transactions, and basically, again, all of these kind of come back to this concept of sharding, and the way that we're doing that in blockchain is off-chain transactions. So we have these networks that are going to run on top of their main net. So
we're still talking in terms of Ethereum, not Bitcoin.
I was actually going to jump back to Bitcoin and
Bitcoin.
kind of give an example there. But for Bitcoin, this is Lightning, and Lightning Network is a network that runs on top of the Bitcoin blockchain, and there is an organization. I'm not sure if they're really a company or more of a nonprofit-like entity.
It is related to Blockstream, I believe, so there is funding behind it.
Yeah, they're definitely funded. Not an ICO, though. I believe they're traditionally funded, and they are working to build this network on top of the Bitcoin blockchain that will basically facilitate lower transaction fees, more transactions per second. That's like really the core of what we're trying to accomplish with a lot of these.
Right. So the big scalability. So the big scalability issue is in congestion in the network.
Yeah.
So one example was CryptoKitties. For Ethereum, just there's a lot of transactions and a lot of work with gas and stuff going on in the chain. With Bitcoin, the primary use case is just transaction speed and fees related to those.
Yeah.
And
yeah.
it just gets congested. So how do you split that up
Yep.
on a decentralized network versus the sharding you were just explaining in a regular database table?
So for Bitcoin, we have the Lightning Network. And then on Ethereum, we actually have a bunch more options. We can get into each individual one, but these include Plasma, sharding, and Raiden is another one that I'm not the
Ride
biggest.
blocks, right?
Yeah, I think that's them. I'm not the biggest proponent of that, but they are also they're trying to help scale the Ethereum blockchain. So we can start with Lightning Network, and basically that's a payment protocol layer that runs on top of the Bitcoin blockchain again, and it's basically creating these two-way payment channels between individual users' nodes. And what this does is that it allows multiple transactions to be bundled basically into a single transaction on the blockchain. So you and I can be part of a network on the Lightning Network. You and I can transact, and those transactions happen instantaneously. And then periodically, we'll commit those records back to the blockchain.
Right. So not everything needs to be written to a blockchain. It's basically the concept that's being taken advantage of here.
Well, it all does get written to the blockchain.
Eventually.
Yeah.
But it doesn't have to happen live.
Exactly.
Just like when you go trade on Bittrex and you're buying, hopefully you're not buying Verge, but let's say you're trading Verge, right? So you buy Verge with Bitcoin, that order gets filled instantly.
Yeah.
And then when you sell Verge to Bitcoin, filled instantly. That's just because it's on a central, I'm going to say SQL database, whatever, on Bittrex's local servers, centralized. That's why it's happening instantly. Once you withdraw your coins to your hardware wallet from Bittrex to your desktop wallet, now that the result of that is pushed to the blockchain. It takes a little longer, et cetera.
Yeah.
So that
Absolutely.
concept.
Yep, absolutely. And yeah, so that's the core of Lightning Network. It's really dealing with these, peer-to-peer channels where we're trying to reduce the load on the main.
Private. It's not public, that's all. It's peer-to-peer, but it's just, these private channels, not on a public chain.
Yeah, it's not on the main net. I believe they are public channels, though. There may be some concept of private channels. I'm not 100% sure there.
Gotcha.
If anyone out there knows, definitely fill us in the comments. But I think there is definitely a portion of it is definitely still exposed, still public. There are definitely private blockchains. That's something else we can get into. And I think that's going to be a huge part of how the technology grows, because I think there's a lot of applications of the technology that aren't.
That don't need to be public.
Yeah, don't need to be public. A lot of big corporations will find use of blockchain technology, this ledger technology, just purely internally. It'll improve operations and reduce costs. There's a lot of benefit there. So I think we'll see a lot of that. But those again won't be like super public or notable projects. Those are going to be
it's for like big global companies
exactly.
around the world.
Chase, when they're trying to do internal reconciliations, an internal Chase blockchain would facilitate that like tremendously.
Yeah.
Of course, Chase is not the biggest blockchain proponent, so they're probably not
owned
the
by
ones.
JP Morgan, our friend Diamond. Yeah.
They're probably not going to be the ones to pioneer that, but they are on the bleeding edge of technology, generally speaking, as banks go. So who's to say what their views may change?
Yeah, they did release a paper. They're into blockchain.
Yeah. Diamond definitely. He started things off rocky, but they've backtracked a bit, and they see the value. They see some value.
Yeah, and so this is not related to. So there's different things, right, to scaling. Right, you're saying sharding. Right now, we're talking about the Lightning networks. This has nothing to do with block size changes.
No.
Got it. So this is just basically like I look at it as a tunnel system.
Yeah, exactly. Yeah. So, and some of it's not complete. It's an imperfect technology. So there's some concepts that I don't fully understand. But like one of the use cases, one of the issues that is out there is what happens when these nodes, and we'll see this throughout the other examples of scaling as well. What happens if you have a dishonest or a malicious node? What happens? So, it's all based on trust. The system should be trustless, but with these off-chain transactions and these sub-chains and these networks that are running on top of the main net, there is a level of trust required, because you're now relying on these other nodes to kind of facilitate transactions. So there are protocols that they have designed where basically if a node is determined to be malicious, there's a method for exiting from that connection, and there's ways to mitigate the risk in losing funds in that happening. You exit and your funds are basically transferred back up the tree. These are all done in Merkle trees, which basically follows the hash tree down from the mainnet, and you create these like subchains. So you basically go back up the Merkle tree to a trusted node, and you retreat.
Gotcha.
And there's also crypto economic incentives for these nodes to remain honest and not be malicious or fraudulent. So I take that to mean that honest nodes will be rewarded in some sort of monetary fashion. Something that has escaped me a little bit is how malicious or fraudulent nodes will be penalized. Is there actually a cost? Are they hit with a fee? I'm not 100% on that, but that's definitely something they're working on actively.
Gotcha. That makes sense. So let's quickly talk about block sizes.
Sure.
And what people mean when they say bigger or smaller blocks, because I've seen a lot of people speculate on it and get into tense arguments on Twitter and Facebook feuds, and they don't even really understand what they mean when they say block size. So first, I think it's important to define these things, right? So we define sort of what a database is. It's this table, just so people can visualize it. And then when people say block size, to define block size, it's just really the amount of data within that section.
Yeah.
Chain. And how
so
the
chain is made up of these blocks.
And how can you reduce the amount of data required in each block? That's what a block size is to me. That's how I would define it, the amount of data.
So this is kind of stepping back a bit because I definitely see the block size issue as something that it's like a patch. It's a temporary resolution. But the block size issue, these sharding and these off-chain solutions are truly how blockchain will scale. So stepping back for a minute, the block size stuff, SegWit, those are attempts that we've done as a community to date to try and
patch it.
Yeah, improve things. So SegWit, what that was doing was basically taking the existing block and separating a portion of it. And that portion contained witness data. That's why it's called the segregated witness. So that witness data was then appended in a new section at the end of the block. And so the main portion of the transaction remained the same. The size of that, the way it was treated, remained the same.
So there are certain things that we save, right? So now it's the size of data. Now what is the data? What are we partitioning? Almost sharding in a way. It's not quite sharding, but it's definitely saying that there's some data that's more required than others.
So it gets pretty technical. There's hashes and transaction IDs that are in that block, but at a slightly higher level.
Maybe something related to quantity.
So that witness portion at the end, that what's changed here is how that is counted towards the size of the block. Blocks are previously measured in megabytes. After SegWit, they are no longer measured in megabytes; they're measured in units. So the units are calculated based on megabytes, but the units that the witness segment of the block takes up is counted at 0.25 the actual number of megabytes. So basically it's done to reduce how much that is counting towards the block size. And it is a bit of a simplification, but that's the core of it. And the end result was that the new block size limit was around 1.8 megabytes, whereas previously it was 1.
Gotcha.
So that's what we've done to date to try and help things scale, to help those transaction times, the number of transactions, the rate of transactions per second. But again, I think that's really a patch, and it helped. It will help.
Yeah, because eventually, as more users get onboarded into the crypto ecosystem, we're just gonna have to make the blocks bigger.
Yeah, exactly. So it's only a temporary solution, and what we're talking about here today, these sharding, plasma, lightning, those are the real scalable solutions. Those will allow for the Visa level transactions per second.
How I view the block size debate is like you're going food shopping and you have a paper bag and you put a bunch of crap in your paper bag and it rips. And then instead of them giving you a plastic bag or figuring out a better solution, they just try to put a second
two paper
bags.
bags.
And it can hold a little more, but eventually it's still going to rip. So you may as well just come up with an actual
I think
solution.
that's all. It's a great oversimplified analogy for sure.
Yeah.
But yeah, it's just a temporary patch. It's not the long-term solution. And yeah, we're definitely going to need to dig down, and it's not going to be easy. I wouldn't say that any of these are actually close to ready for production. Lightning is probably the furthest along. They're
And you
also
can actually fool around with it somewhere, right?
yeah. So the Lightning,
There's actually
you
test
can
nets.
yeah.
Right?
There's test nets. You can set up your own test net. You can see how that all works, and it is very cool. I'd say that is the furthest along, and given that they no ICO, they raise traditional funding and they have the most to show for it.
They have more at stake in some ways.
That speaks to.
And they have Adam Beck, and they have some like.
Oh,
just
it's a
the
very
big guys,
real team. Yeah. They're no question the right minds for the job.
Yeah.
But yeah, Lightning I think ultimately is the furthest along and probably the closest to being production ready. But all of these are ways down the road, and it's going to take some work and patience, and it's not going to happen overnight. But this is definitely the solutions we need to be working towards. So, if you're good on block sizes, I think we can discuss the Ethereum component of this and how the different ways that Ethereum is trying to scale. So, since we're just coming off of Lightning, we can talk about Ethereum's Lightning implementation, which is called Raiden. So that Raiden again is a scaling project on Ethereum, but really all it is a Lightning implementation on the Ethereum blockchain. They ICO'd. I believe that they have a pretty good reputation. I've heard good things. I've also heard some questionable things, but they're trying, and it'll definitely be interesting to see where that goes.
So they're governing off smart contracts.
No, that's Plasma.
I
Yeah,
keep mixing those up. So this is really just a Lightning Network implementation.
Yeah, this is a Lightning Network implementation on the Ethereum blockchain. So they're taking the idea that the Lightning Foundation, I'm not sure what it's called, had, and they're applying that to Ethereum, which is above board. I don't think there's any issue with doing that kind of thing. I'm pretty sure Lightning was released as an open source concept, and they're happy to have other developers working on it on other blockchains. But yeah, so that's pretty simple. That's really what Raiden is. And then we can get into Plasma. So Plasma definitely gets a little more complicated, and this is something that is actually worked on by the Vitalik's team, Ethereum Core. I don't know if that's really the way to refer to it, but Plasma is smart contracts. So this is pretty cool stuff. Plasma is a framework for incentivized and enforced execution of smart contracts that allows for a significant number of updates per second. So in the billions of updates per second. So
updates per second does not mean transactions per second.
No, that's what it's indicating. Yeah. So the Plasma network runs on top of the Ethereum blockchain. So it's the same concept. You have this subnet, and Plasma is a series of smart contracts that create and govern new subchains, and I believe that's actually how they refer to it for Plasma, child blockchains. So you have these smart contracts, and they're designed to basically they're kind of like load balancers. Basically, as there's load on the network, they create this subchain. They route transactions through the subchain, and the same concept. The transactions are happening off of the mainnet, occasionally getting committed back to the mainnet. This reduces transaction times. This reduces transaction fees on Ethereum. This is the gas necessary to process the transaction, and those sub chains are also governed by those smart contracts. So that's how they deal with fraud, and that's how they deal with malicious actors and the that sort of thing. So Plasma is really cool. Plasma is a ways out.
Yeah, sure.
All of these solutions, particularly the Ethereum teams solutions, those are all in development. From my research, it seems like possibly years out. I know there was talk about seeing some implementations of these in 2018, but I think they were saying that they would have something ready in early 2018, and we're in early 2018, and I haven't seen anything. So again, this is to no fault of theirs. These are very complex problems to be tackling. So we need to give them the patience that they deserve for trying to solve these problems for the community. And people getting really angry and getting into arguments online about, how this is going to happen and is it happening fast enough? When is it going to happen? Ethereum sucks because CryptoKitties, brought the whole network down. Those people aren't in it. Don't seem like they're in it for the long haul. We need to realize that this is,
and they've clearly never dealt with software. I mean, they don't understand how this works.
Yeah, this is definitely a work in progress. We're iterating, as quickly as possible, but this takes time.
Yeah.
So that's the core of Plasma. I know that there's Vitalik was also talking about the potential for Plasma tokens, which would encapsulate some of that functionality into a token that you can just hold instead of running a node. Yeah, that's Plasma. So we can.
So there's I think the Lightning Network I'm really excited about. I think that we're going to see that in late 2018 potentially.
Yeah, so I mean, we didn't talk about it. We can talk about it. Lightning Network is they're also doing atomic cross-chain swaps, which I think is probably one of the coolest things that's happened in crypto in the last year or two. Atomic cross-chain swaps means that that you can basically exchange Ethereum or Litecoin for Bitcoin or Ethereum for Bitcoin, or but allowing to swap between these coins, chains without an intermediary like an exchange. So it's some pretty complex stuff, but they do have a proof of concept where they did swap Bitcoin for Litecoin, and there's a lot of assumptions when this happens. So there's an assumed conversion rate, and that's that's something that obviously I don't know if it really scales or if that's really production ready, and that kind of gets into like oracles. We need ways to get data from off the blockchain into these like smart contracts and onto the blockchain so that we can do smarter things with blockchain technology.
Big data into it.
Yeah. So that's getting a little ahead of ourselves, but yeah, atomic cross-chain swaps are a very cool thing. I'm really excited to see where that goes. And yeah, Lightning all in, I think they're doing the most with some of the smartest people, and I think that my money would definitely be on that to be the first solution out. And it really could bring Bitcoin forward. Another thing I didn't really mention, there was, in limitations of the Lightning Network, there was actually a DDoS attack on the Lightning Network just a couple weeks ago, and that did bring the network down. It shows that it's not finished, it's not production ready. We've got some things to fix, but the fact that someone's DDoSing it means that
they care.
Yeah, they care.
Yeah,
someone out there loves you.
Yeah.
But yeah, I would agree. Lightning is very cool. Lightning is definitely.
So yeah, for everyone's talking about how these blockchains can't scale and won't scale, I've seen a lot of haters. I'd like to say that they're wrong, and there's a lot of very dedicated teams working on this, right? So we understand the relational database starting and then bring it to blockchain. There's Lightning Network, Raiden, Plasma, and I'm very confident they're going to have a solution, and this will be brought to the masses and be able to handle the masses.
Yeah, I agree.
Haters going to hate.
Haters going to hate.
So,
and then the last method for Ethereum scaling, the big one is sharding, Ethereum sharding. And again, so that's like, it's the same premise. You're taking, well, let's step back for a sec, I guess. So Ethereum, the way the network operates, you have nodes, and the nodes need to all reach a consensus for the transaction, for the blocks to kind of move forward. So this is not the most efficient way to do things, because you're waiting for all of these nodes to computationally process the information and come back with a result saying that this all looks good. We're going to confirm it. That's the core of why we have these rate limits, these transactions per second limits on the blockchain. So what sharding does, sharding basically splits up the blockchain, and each node only needs to be responsible for the network that it's operating around. So it doesn't know the entirety of the blockchain. And there, as Vitalik put it, there will be mechanisms and protocols for nodes to communicate with other nodes so if you need to transact with someone that's not in your network, your immediate network, your shard, there will be a protocol, a mechanism for you to make that transaction happen. But that's complexity that hasn't been fleshed
So I'm
out.
saying the concept of splitting up a database where just like the users, if it's A through C, D through F, G through H, it only knows its tables.
Yeah.
It could still transact
Yeah.
with other ones. Yeah.
So I'm not 100% sure on how the shards are broken up, whether it's geographically or based on some other mechanism, but that is the core concept. So you have, smaller networks that are committing back to the main blockchain periodically, and they're really just operating within their central network. So this, again, we get into trust issues because bad actors. What if you're connected to a node that is malicious?
Yeah.
So again, we come back to they have exit mechanisms where if a bad actor is detected, you're able to exit the transaction. And I know I was reading that there are mechanisms that allow you to get out of the transaction before any of your money is at risk.
That's huge.
Yeah. So yeah, they're doing a lot. I think that I could be wrong on this, I may be misspeaking, but I'm pretty sure sharding is contingent on Ethereum's Casper release, which is their proof of stake
being implemented first.
Yeah, so Ethereum's Casper protocol, which is their proof of stake protocol, that will be the groundwork for Ethereum sharding, as I understand it. And that covers the big Ethereum
efforts
the big
being done.
efforts on Ethereum to try and scale, and Bitcoin as well. And I think those are all the real scaling projects that are the big ones. And we could get into oracles briefly. So oracles, as I mentioned,
So a lot of people don't know what oracles are too. I learned.
So oracles, we mentioned this a few minutes ago briefly. Oracles are a mechanism for pulling data that's outside of the blockchain into the blockchain.
And generally, oracles deal with big data.
When I was reading about it, it didn't seem to indicate that it needs to be like a big data set. It could be something as simple as like weather data, which I guess you could view as big data. But so as we want to grow on the blockchain, we want to do more complex things. We want to get into applications in real estate where you can hold maybe deeds to land on the blockchain. We need to have there's secondary and tertiary information that we need to know that doesn't reside on the blockchain. So what is the secure method for bringing this information in, making sure that it's honest and accurate information, and then distributing it for use to the network? So that's where oracles come in. Oracles are this concept that we'll have a network of nodes, same concept as many other things on the blockchain, and they'll all kind of hold the data and validate the data.
Yeah.
So that you always knowing that the data you're pulling in is good and true and accurate because it's been validated by this network of oracles. And again, there's crypto economic incentives for being honest and not being malicious. You're financially rewarded for being a good operating node, and then there's some fee or penalty if you're a malicious node spreading false data.
Right. Makes sense. And there's a cool Ethereum token out called Zap, which is working on these Oracle feeds to go into the blockchain. Yeah,
and it's going to be a huge thing because in order for us to get past these basic currency tokens and stuff like CryptoKitties, which is very trivial, we're going to need that outside data. We're going to need real world data, and we need that to come in a reliable, trustworthy fashion. So I think oracles are going to be big, and we'll see over 2018 and building into the future. This will be a very important part of blockchain.
Yep, more ICOs to come for
more
oracles.
ICOs to come. Yeah, for sure.
Yeah.
So I think that's just about everything I had on this kind of technical scaling discussion.
Yeah. No, thanks for the lesson. No, I think it was helpful. I've seen, because I've seen a lot of people speak about scaling and they have no idea what they're talking about, and they're only talking about Lightning Network. And then people are just throwing out words like sharding and plasma, and it's very obvious that they don't know what they're talking about.
It's complicated.
It is complicated. And this was very brief, but I think it opens. I just hope that people took away the basics.
Yeah, I have a technical background, and my understanding of traditional sharding, how you take that relational database, what we explained earlier, and you make it more scalable. that's something that most people don't understand. So that fundamental concept definitely helped me get it. But once you start to understand that high level concept of how sharding works and how you're spreading the data out to make it more accessible, make it more reliable, you can kind of see how that applies in slightly different ways to blockchain. And all of these projects are really taking that core concept, really trying to apply it to the blockchain. Yeah, splitting up data.
That's really what sharding really is. It's splitting up data.
Yep.
Interesting. Cool. Yeah, no, that covered what I wanted to get across here. And,
awesome.
Yeah, so I guess we will catch you next time.
Yeah. Cool. Thanks, guys. If you have any thoughts or comments, questions, leave us comments down below.
Adios.